Are we rolling? I think we're rolling. Hey, we're rolling. Hello everyone, we're back. Lesson 2.1 on file input output, otherwise known as file I/O. So the backstory here, the motivation is that in our previous lessons we've done a lot of variable declarations, and that's a way for us to store information in the random access memory of the computer so that as long as a program is running, it can use that information, it can use those stored values. Very often, however, we need to store and access information or data for a much longer time. So if you think about data that you might collect in a lab, sometimes you'll be taking that data and write it down in the lab notebook so that you can have it forever. Sometimes you'll be taking that data and either entering it into an Excel spreadsheet or something like that, or this instrumentation that you'll be using automatically puts that data into a spreadsheet or some type of file format. And then you can save that on your computer, keep it forever, keep it for as long as your computer exists, put it on the cloud, and access that information later. Python and many other programming languages give us really convenient tools for writing information to file input, and reading information from file output. I think I got those backwards actually. So writing to file we call output, so writing information to a file, we're outputting information to a file. Reading information from a file, it's serving as input to our program. So I'm going to show you some techniques for doing that. At the end of the lesson, you'll probably be scratching your head thinking, yeah, well, why wouldn't I just do that in Excel? There are actually very good reasons why you would not do that in Excel. When you use a spreadsheet program like Excel, your data and your analysis code are all the same thing. They are the spreadsheet. Problems can happen. If you accidentally overwrite the data in a cell or you type in an equation incorrectly, something like that, all heck can break loose and you might not even notice it until your results go to publication, and then it turns out they're wrong and you have egg on your face and you feel like a goober. Here's an example of that. You can read this article. It will probably make you angry, but it's an example of data analysis gone wrong. All right, so let's jump into the techniques here. The syntax for writing to a file in a simple way is incredibly straightforward. So I create a file object. Here I'm giving it a variable name output file. And I do that by using this open function, which is a Python built-in function. I provide open with two arguments. The first argument is just a string that is the file name. So I'm going to create a file. This is what I want that file to be called. The second string is usually just a single letter, and it tells me it allows me to tell Python what I'm going to do with this file. So here W means that I'm opening that file up in write mode. I'm going to write data to this file. I then in this code snippet create a string variable, hello world, or a string type, a variable that has a string type in it, hello world. And then I do output file, which is the file object, and I use this write function. What write is going to do is it's going to print the value in that statement variable to the file. I then close the file. Okay, so this is not earth-shattering. When I run this block of code, check this out. When I run this block of code, and then I go back to my kind of Jupyter Notebook browser here, I see that in this directory, in this folder, in addition to the notebook file I've been working in, I now have a file called testfile.txt. Well, that's the name of the file that I wanted to create. If I double click on this thing, I can actually look at the contents of this file. So that string, the string information that I wrote to file, is now saved in this file on the computer. This is an incredibly easy way to manipulate files. You know, we didn't have to open Microsoft Word to open up a Word document and then do a bunch of formatting and stuff. We just wrote this information directly to this file. So I'm going to close this tab and we'll go back to our notebook here. All right, so that's kind of all there is to writing information to file. If I wanted to make this more complicated, I mean, maybe I could do something like put this in a loop for I in range 10. We'll do this 10 times. So statement equals, I'm going to cast my my iterator as a string, and then I will do something like that. And then I'm going to write statement, okay. And then once all of this loop is over, I'll close the output file, something like this. If I run this code cell, I can go back to my directory browser and I'll see that we've created a new file. Actually, let me update this page. We created a file, testfile.txt, 9 seconds ago. If I click on this thing, hey, well, it kind of worked. It didn't do exactly what I had in mind. It just printed these things one right after the other. I really had in mind that they would be on separate lines. Let me show you how to do that real quick. So let's close this guy. If I want each one of these statements to have a new line character at the end of it, I have to do something like this. So /n, that's the backward leaning slash, the key that's right above the return key on your keyboard. N means, hey, end the line, make a new line at the end of this string. So I'm going to run this block of code. I'll go back, I'll open this file, and that's more what I had in mind. So this output file.write or file.write is a really convenient way to write information to a file. You can see it's very flexible. We could do all kinds of different stuff with this. Let's see if we can synthesize a few of the techniques we've learned so far with a warm-up problem. So we're going to write a snippet of code that creates a new file called tonsofnumbers.txt, and it writes 100,000 random numbers between 0 and 1 into this file. Each line of the file should be a single number. Hint, put it in a loop. Okay, all right. So what I'm going to do is I'm going to open a new file. I'll call it ton for tons of numbers is equal to open tons of numbers.txt. And I want to give Python that little character that tells Python how I'm going to use this file. I'm going to write information to it. Then I'll do like a loop for I in range, 100,000. Okay, I know a cool mistake I can make here. So I'm going to do rnum is equal to ran.random like this, and then I'll do ton.write. I'm going to cast rnum to a string. And then to this, I'm going to add that new line character, as it's kind of suggested we do here, so that I have one number per line in the file. Okay, that's going to happen. And then I'm going to do ton.close to close my file and just let my file system know that I'm done with this. All right, this block of code is going to fail. I will pause for 2 seconds to see if you can figure out why it's going to fail. Then I'll run it and we'll find out why it's going to fail. So 1 Mississippi. To Mississippi. I'm going to execute this block of code. And it's telling me we have a runtime error. This is a name error. Name rand is not defined. So I tried to use the random library, and it's telling me here that that's not something that this block of code knows about. And the reason for that is I need to first import that library. So I'll do just like we had in the previous lesson, import random as rand. So bringing that knowledge in the random library into this chunk of code. Let's execute this now. Hey, it ran. Okay, good. So we didn't get an error. Let's go to our file browser. We now have tons of numbers here. I can click on this thing, and goodness, there are literally a ton of numbers in this file. Look at that. So that's great. We just created a really, really big data file. There should be 100,000 lines of data in this file. That's a lot of stuff. We did it in the blink of an eye. And now this file is saved on our computer. We could access it later. The next section of this notebook goes into quite a bit of detail about strings. Now, in a previous lesson, I talked about strings in a lot of detail. We don't really need to go back through, in this video, we don't need to go back through all of the string information. You should read it at your leisure as you work through this notebook file. The main takeaways here are 2. So the first is whenever you do a file write or a file read, like we're going to talk about in a minute, Python assumes that what you are writing or reading is a string. So there might be a way for Python to write an integer to the file, but when you read that information out of a file, even if you know in your mind it's supposed to be an integer, Python will read it as a string. So there's some, we have to be aware of that and make sure that we recast that data appropriately. You can see there's some string manipulations in this section. The other thing that we need to talk about is a function that's built into the string type or string class that we didn't talk about before. This is the function called split. Split is an incredibly powerful tool. It's a very simple tool, but it's an incredibly powerful tool for doing file input and output. All it does is it takes a string, if you call split on that string, split will split up the string into a list at every location where there's a character that you specified. So check out, here's a little example. I have this big long string that's stored in the variable called smoothie ingredients. The string is apple, comma, spinach, comma, carrot, comma, yogurt, comma, blueberries, comma, protein powder, comma, motor oil, comma, honey. If I print out this string, print smoothie ingredients, I get a big long string. What I can then do is convert this string into a list of the ingredients by doing smoothie_ingredients.split, and I supply a comma. What this is going to do is it's going to split this string up into a bunch of smaller strings. It will split everywhere where there's a comma. So you could think about coming in here with like a knife or some kind of chopping implement and chopping this string, a sword maybe. Chop, 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 slash. Chopping this string up everywhere where there's a comma and then turning the little individual pieces that I cut apart into a list. So when I run this, we start with this big long string right here. That's my first print statement. I then split that string into a list and I print out the list. Here's the list printed. You can see the elements are separated by commas, but between square brackets. And then I can loop over the ingredients in the ingredients list. So for ingredients list, this thing, print the ingredient, and I'm using this other function called strip, which basically just removes any white space, any spaces that are at either end of, whoops, where are my hands? At either end of the string. So you can see I go from having a big long string to a list of smaller strings, and then this iterated over list where I'm just printing out the individual ingredients without any leading white space or anything like that. This thing split we use all the time. So it's convenient to store data. We'll get into this in a minute. It's convenient to store data in a file separated by commas. If the data is stored in a file separated by commas, you can read it into your program and do a split on that string that has commas in it to split it up into individual data. I'll show you how that works very soon. Okay, so we figured out how to write data to file. Let's talk about the syntax for reading data from file. It looks very, very similar to writing data to file. Now, before I go any further, I want to go back up to the first thing we did and just revert back to what this looked like at the beginning of the lesson, because I want to make sure that this later code cell is going to work. So I'm just going to get this back to a very simple 4 lines of code that open a file, write hello world to the file, and then close the file. I'll check out that file just to make sure it's looking like we think it's supposed to look. There it is, hello world, super duper. All right, so let's go back here and let's go back to this reading from file example. All right, so check it out. I do basically the same thing. I'm going to have a variable called input file. I link that to the file I want to read by using open. I'm giving Python the name, the file name of the file I want to open, and I'm also telling it the way in which I want to work with this file. I want to R for read information from the file. Now, the file access type, either W or R, might seem like, well, why do I have to do that? It just seems like a waste of time. I'm opening the file. This is actually very important for data integrity reasons. If you open up a file and you want to read information from it, you really want to make sure that you're not accidentally manipulating that file. You're not accidentally writing or overwriting data in the file or adding new information to the file, because that is bad. You might accidentally or intentionally falsify data. You might change your data, which would invalidate your results. So this is actually a very important feature of file input-output in Python, or from a programmatic standpoint like this. So we open the file. I then call input file.readLine. That is a function. Readline is a function that reads a line off of the file. So I'm going to read a line off of the file, store that information or data in a variable called line. I'll print line, and then I'll close the file. When I run this thing, check out what I get. I get hello world. That was the information that was stored in the file. I could do the same type of thing. I could change this to tons of numbers, and rerun this, and what I will get is the first line, the number that is the first line in my tons of numbers file. I'll change this back to testfile.txt. Okay, great. So just like we previously put the output file.write in a loop, we can put input file.readline in a loop to successively read lines from the file. So we'll go to this next warm-up problem. Here's another warm-up problem. We're going to read in all of the numbers in the tons of numbers.txt file and count how many are greater than 0.75. All right, so I'm going to do this. In file is equal to open tons of numbers.txt, and I want to access this thing in read mode. Nice. Then, oh geez, I have to figure out some way to read all of the lines out of the file. Now, we happen to know that there are 100,000 lines in this file. So I could set this up as a definite loop for I in range 100,000. I will do line is equal to infile.readline. And maybe I don't want to print that out because that's a lot of information. So what are we supposed to do here? We're counting how many are greater than 0.75. So I probably want some type of variable that's going to count this up. I'll call it number greater than n_gt. We'll start it at 0. All right, and then I need like a conditional here. So if line is greater than 0.75, this is not going to work. Maybe you can figure out why it's not going to work. We will increment this ngt equals ngt plus 1. And then at the end here, we'll print ngt. Okay, this is not going to work. Maybe you know already why. I'll talk about why in a minute. Let's just review what each of these lines is going to do. We open the file in read mode. We establish a counter variable. We started at 0. We set up a definite loop to loop over all of the lines in the file. We know ahead of time that there are 100,000 of those things. We read the line. We check whether the number that's in the line is greater than 0.75. If it is, we increment our counter. All right, let's run this. Not going to work. Why is it not going to work? Well, we have a type error. So type error greater than is not supported between instances of string and float. This goes back to the previous lesson where we talked about some types of operations are not well defined for different types of data. There isn't a good way to compare whether a string is greater than a number. This goes back to what I said a moment ago about when Python reads information from file, it just defaultly assumes that that information is a string. It reads it in as a string. So what we want to do is we actually want to cast this line, the datum that we're reading out of the file, we want to cast it as a float. We want to tell Python, hey, you just read a string from the file, turn it into a float, and then check to see whether it's greater than 0.75. All right, let's rerun this. Hey, we did it. The number that we get is 24,877. That's about a quarter of the total number of numbers that are in this file. That's what we would expect for a list of 100,000 randomly generated numbers between 0 and 1. So this looks good. All right, I'm going to leave this other warm-up problem to you. I guess I'll leave, oh my gosh, who wrote all these warm-up problems? Okay, I'm going to leave these other 3 warm-up problems to you. They hinge on treating the line that you read in from the file, tons of numbers, as a string rather than as a number. And there's some information and some examples in this section up here about how to access the individual characters in a string. You can figure it out. It would be a good test, be a good warm-up problem for you. All right, where are we? Okay, let's talk about reading in tabular data. Now, the files that we've made, that we've written to and read so far were pretty simple. They just contained basically one type of datum in them, or one type of data, and each line in the file had a single type of data. More often in the sciences, we wind up working with things that actually look like spreadsheets. So here's an example. This is an example of what we call a relational database, We have rows. Each row in the database corresponds to like an instance of something. This is a database that contains information on students in a class, their class year, what row they sit in, and whether or not they're cool in a 0 or 1 Boolean type way. So each one of the rows in this file contains more than one piece of information corresponding to that instance, and those pieces of information are separated in classes. If you've used Excel or Numbers or something like that, the Mac program Numbers, this looks very straightforward. It's a table. It's a table of data. The way that we would work with data like this from a programming standpoint is we would store this information in what we call a comma-separated value format. So we would have a file. Each line of the file would correspond to one of the rows in this data set, and the individual columns of data would be separated by, the individual features would be separated by commas in each line of the data file. So you can check out what I mean by this. If you look at a data file called parabtxny.txt that's available on GitHub, so I'll show you how to find that right now. If we go back to the GitHub page, I'm going to go back to the main repo for STEMNetX coding camp, and you'll see that we've previously been grabbing files out of the async workshop directory. We can also look in data files, where we have a whole bunch of data files that we'll use in this lesson and throughout a bunch of the other lessons. So here's the, so I guess it's called parabtny.csv. I'm going to click on that, and we will, of course, download the raw file. Now, what I need to do is I need to find where this file exists. Let's see how this is going to work. I actually don't remember how this is going to work for us. Let me go back to where we want to be. All right. So let's try this. I'm going to upload. I'm going to find where I downloaded this thing. Downloads. Please don't look at my downloaded files. It'll be so embarrassing. Here it is, parabtny.csv, and it just got added to our kind of working directory here. All right, so let's go back to our notebook file. Or actually, let's take a look at this parabtny files already. So when we click on this thing, our Jupyter notebook opens it up in this tabular format because it kind of knows what to expect here. It's telling us that the delimiter in each one of these rows, delimiter just means what's the character that separates the features in each one of those rows, is a comma. So it's done some formatting for us because it knows that this thing is a text file already. However, if I go to, let me just show you what this file actually looks like, cd downloads, and I'll just do vs, all right. So I'm going to open this thing just as a raw text file. Of course, Visual Studio Code has to be verified. Oh, goodness. All right, this is what it looks like. So I have a whole bunch of lines of information. There are 50 lines with information in them in this data file. They contain, each line contains 2 values. The values are floats, so they look to us like floats. The 2 floats in each line are separated by a comma. So there you go. This is a comma separated value format file. That's what the .csv file extension means. All right, so let's get rid of this. Okay, so how are we going to actually access this thing? Well, here's some code that will read this in. And I wrote all the code here already, so this is an example. You can kind of parse through it and see how it works. The first thing that I'm going to do is import another library called NumPy, which is short for numerical Python. We'll talk about this later. Don't worry about it for right now. Then I'm going to pull the same type of shenanigans that we had before. So I'm going to open up the file I am looking for. I happen to know that I have this file in this directory now, so I don't need this data files / thing. parabtny.csv lives in the same directory as this notebook file, so I can just open it directly. Then I create 2 empty lists, one for the t values and one for the y values. I'm then going to read the first line out of the file, just so I kind of have it in memory already. Then I have a while loop as long as there's information in that line I just read. So len of line is going to check the length of the line that I read. If it's greater than 1, that means that there's some data in that line, and then I'm going to start to process it. So I take that line and I split it into a list. It's a comma separated values file, so I split it everywhere where there's a comma. I cast the 0th element of that list as a float, and then I store that in the variable t. I cast the index 1 element of that list as a float, and I store that value in variable y. And then I just append those values to the 2 lists that I created before. So I'm starting with a comma separated value data file. I'm reading it in and creating 2 lists of data out of that file. This is the way that I do that. Everything below this line we'll talk about in a future lesson. It's just going to basically make a nice looking graph for us. So let's see if this block of code runs. Hey, it does run. So it reads in the data, it converts it into 2 lists, one for the time values that's shown on the horizontal axis, one for the y position values that's shown on the vertical axis, and you can see this nice graph shows us that this data looks pretty darn parabolic. The takeaways from this block of code are just that we use this same type of read line thing inside of a loop to successively read off lines in the file. And we use split in order to split up those comma separated value strings into the data that we want to append to lists. All of the other stuff down here we'll talk about in a future lesson. So I guess one other thing that I could say about this, if we go back to the data files directory, so that data file I just read in has 50 lines of data in it. There's also a parab t and y underscore 100k .csv. I think I can download this thing directly. Let's just click on it. Let's see if we can, yeah, we can download this. So there's so much data in here that GitHub is not going to show us the file. It just says, sorry about that, but we can't show files that are this big right now. We're going to download the file. Okay, it downloaded. I'm then going to upload it to our working directory. So same thing that I did before. Where is this parab t and y 100k.csv? Okay, then check this out. So we pretty quickly read in 50 lines of data. I can almost just as quickly read in 100,000 lines of data. So I change the file name, and then I can use this block of code over again. It read in 100,000 lines of data, processed them, and made a graph very, very quickly. This would be very difficult to do in Microsoft Excel. Dealing with a spreadsheet that has 100,000 lines of data and then making a graph out of that thing in a point-and-click program, piece of software like Excel, is really, really memory intensive. It takes a long time. There's a lot to look at because you have to actually, highlight all of the rows in the spreadsheet that you want to make the graph out of. It's really, really complicated. A programmatic approach or a procedural programming approach like this is much more suited to analyzing and working with large data sets, which is the era of science that we're now in. Okay, so you can read this little section. You may ask yourself, why on earth would I go through the trouble of programming in Python something simple like this? Couldn't I do it with Excel in 5-ish minutes? Possibly. Read these 3 reasons that I came up with why you probably do not want to do that in an actual research setting. Okay, let's do a live demo. How about that? So there are 2 live, there's 1 live demo and there are 2 homework problems. I'm going to do one of the homework problems if you're okay with that. You can't tell me if you're not okay with that, so I'm just going to do it. All right, so problem 1, you own a casino. To prevent cheating, your casino monitors the outcomes of dice rolls at one of its craps tables. So craps is that game where people roll 2 dice and then they win money or lose money somehow, depending on the outcome. I don't totally know how it works. Outcomes for 10,000 rolls are given in the file dicedata.txt. Read in this file and do the following analyses. How many times did the thrower roll snake eyes? That's a 1 and a 1 on the 2 dice. How many times did the thrower roll boxcars? That's a 6 and a 6 on the 2 dice. And then how many times did the thrower roll dice totaling 7? And then I will leave the 4th of these bullets to you. So you own this casino. After reviewing the data, do you suspect that something fishy is going on? So from the dice roll data. All right, let's get this data set first. So where is it? Dice data. Okay, so this is actually displayable. We'll download this thing. This is a comma separated value data file, and you can see what the different roles in the data file look like. There are 4 columns, so we have role, die 1, die 2, and the name of the croupier. That's the person who manages the craps table. And then we just have the values in here. So the roll number, die 1, die 2. I should also mention, you know what, we will look at this file. So let's look at the raw text file here. So just like we did before. Now there's something different about this file, which is that the first line of the file is what we call a header row or a header line. All that means is it contains a name for each of the columns in the file, telling us what the data in that column signify. So the first column is the roll number. The second column is the number that came up on the first die. The third column, sorry, is the number that came up on the second die. And then the fourth column is the name of the croupier. So I've opened this in Visual Studio Code, which very conveniently color codes the data for me because it knows how to deal with CSV files. But you could probably open it in Notepad++ and it would do something like that. Okay, that's a little bit too small. All right, let's get rid of this. So we've downloaded that data file. I want to upload it to my working environment here. So I'll just find dice data in my downloads. There it is. And then let's do the problem. Okay, so the first thing is I have to open this file. I'm going to do open on dicedata.txt, and we'll do that in read mode. Great. Then we know that that header line is the first line in the file. I'm going to do header is equal to dd.readLine, and we'll just read that off of the file and kind of get rid of it. So we'll read that first line off of the file and then basically ignore it. Then what I want to do is I'll do like dice line is equal to dd.readLine. Now this is the first row of data, actual data that's in the file. I then want to create a while loop that says like while the length of dice line is greater than 1. It's the same structure that we had above. So this loop is going to continue reading lines out of the file until it reads a line that doesn't have any more information in it. Then we'll be done with our program. And let's just do this. So we'll print dice line just for the heck of it, just as a sanity check to see if we're getting what we think we're getting. Then I have to read the next dice line. Dice line is equal to dd.readLine, like that. And then we'll do dd.close. Okay. So pretty cool. Actually, you know what else we'll do? Let's do this. So we'll do n lines. We'll have a counter that counts up the number of lines. And each time through here, we'll do n lines is equal to n lines, plus 1. So we'll count up the number of those things. And then down here, we'll just print out n lines. So just as a couple sanity checks, we weren't asked to print out each line. We weren't asked to find the number of rows in this data, although we're told that it's 10,000. So let's see what we get. I hope we get 10,000. Oh goodness, that would be embarrassing if not. Well, we didn't even get to getting 10,000. Dice data, oh, it's not dicedata.txt, it's dicedata.csv. So let's look at the error we get. Runtime error, file not found. That's pretty instructive error message. No such file or directory, dicedata.txt. The problem is that I wrote dicedata.txt and our file is called dicedata.csv. That was a rookie mistake. But that's the kind of mistake I make all the time. All right, what went wrong? N lines, oops. Okay, so it's telling me name error in the 9th line, n lines is equal to n lines plus 1. N lines is not defined. That's because I called this variable n line. That's embarrassing too, but everyone makes mistakes. Let's try it again. Hey, there we go. So check it out. We're getting a bunch of lines from the file. Oh my gosh, there are so many. I'm just going to cheat and scroll all the way down to the end. And the last thing that we get printed out is the number of lines. We find that it's 10,000. So it looks like this code is working. It's successively reading in each of the lines in the file. Okay, so the next thing we want to do is we want to launch into some of these analysis questions. So let's do the first and the third one, because the second one is basically just more of the first. So let's do this. I'm going to establish a new variable called nSnakes that'll just count up the number of snake eyes. And what I need to do is I need to check if the n equals 1 index and the n equals 2 index values in this string that I read in for each line are both equal to 1. So I guess what I'll do is this. So instead of printing the line, I'll do like line list is equal to dice line dot split, and I'll split everywhere where there's a comma. And then I have to, what do I have to do? So I increment the number of lines, that's still good. Then I want to check whether the first die was a 1 and the second die was a 1. So I could do this. If line list element 1, so the 0th element is just the roll number. The first element, the 1 index element, is the value of the first die. If this thing is equal to 1, and line list 2, that's the value for the second die, is also equal to 1, then I'm going to increment nSnakes. That's such a great variable name. I want to pat myself on the back. Great variable names. Plus 1. So I'm going to increment the value of that thing by 1. It's just going to count up. So here we'll print out the number of lines and the number of snake eyes, or nSnakes. That's looking pretty good. Let's just review here. So we read this thing in, we read the line in, we split it into a list, we increment the number of lines, we check to see whether the index 1 element of the list is equal to 1, and we check to see whether the index 2 element of the list is equal to 1. I don't think that this is going to work for a very specific reason. Let's see what happens. I'm going to run it. Okay, so we printed out the number of lines, we get 10,000. We printed out the number of snake eyes, we get 0. That is unlikely. That would really be a sign that something fishy is going on at this craps table, that no one ever rolled snake eyes in 10,000 rolls. And the issue is not that there's not necessarily that this croupier, this craps table is crooked. It's that I am comparing something that is a string to something that is an integer. It's definitely the case that a string is not equal to an integer. So even if the person did roll snake eyes, line list first element would be a string of 1, and line list second element would be a string of 2. So I need to find some way to actually compare apples to apples here. What I'm going to do is I'm just going to cast each of these strings to ints. So I'm comparing the int casted second and first elements to the corresponding ints. Let's run this. Hey, look at this. So out of 10,000 total rolls, we find that the number of times that the thrower rolled snake eyes is 287. That doesn't seem obviously alarming to me, so that's good. All right, so item number 1 is done. We're going to skip item number 2. Let's do item number 3. How many times did the thrower roll dice totaling 7? So the same type of thing. I'm going to count up the number of times something happened. I'm going to call this number 7s, like that, and 7s. And then I just need a new if statement. If int line list 1 plus int line list 2 is equal to 7, we'll increment the number of 7s. There we go, like this. So same type of thing. And notice that I'm not like starting a new piece of analysis code from scratch. I already have the bones of code that open the data file, read through the lines in the data file, split it into a list of values, and then I can just add on some more analysis code, one more conditional here. Let's see if this works. I'm just gonna do this. And actually, you know what? I will do some more formatting here. Number of lines. This is just good practice. Okay. So then I'm gonna do a /t for an add a tab character. And let's do this. Check out how I'm gonna format this. This is gonna be great. Whoops. Number of snake eyes and snakes, and number of sevens. Okay, and then I can get rid of this stuff. So you can see how this one simple piece of code, we just keep adding more analysis machinery to it. Then we've got some nice format out here. So is this gonna work? N lines and snakes and sevens. Yeah, let's check it out. Okay, so out of 10,000 dice rolls, we get 287 snake eyes, and we get 1,649 totals of 7, which is kind of cool. That was pretty quick to blast through this homework problem. So there you have it. We're going to use this file input-output technique a whole bunch more in this class. I mean, you probably could have guessed that by looking at the number of files that are in the data files directory here. We're going to be working with a lot more data because that's what we do in the sciences. But the kind of core skills that we covered in this lesson are going to be very, very useful over and over again. So I'll leave it there. I'll see you online. Thanks so much for your patience and attention. Talk to you soon.